Hi everyone, welcome to the new session. In today's session, we are going to learn about two different functions, identical function and piecewise functions. Okay, so let's get started. Okay, so identical functions. Okay, as the name says, identical functions means the functions that are identical. Okay, so here when we talk about identical functions, it means we are talking about two functions. Okay, it can be more than one functions. Okay, it can be two, it can be three. Okay, because if the functions has to be identical, then they have to satisfy some conditions. You can put those conditions on two functions, you can put those conditions on three functions, you can put it on 4, 10, 15, any number of functions, right? So two functions are said to be identical. Okay, let's say that we have two functions, f of x and g of x. Okay, these are the two functions. Okay, let fx and gx are two functions. Okay, so these functions are said to be identical. Okay, these functions are said to be identical, which means that fx is going to be same as gx when 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 fx and gx are going to be same. They are going to be same if their domains are equal, means the domain of f and domain of g both are equal. Okay, these two functions, they are said to be identical when their number one, when their domains are equal, number two, when their ranges are equal, right? So these two functions are said to be identical when their domains and ranges are equal. Okay, and then I can say that fx is going to be identical or same as gx for all x belongs to domain of f or x belongs to domain of g, right? So what does it mean? It means that this function is equal to the f function is equal to g function when for all x belongs to df or x belongs to dg. Why? Because dg and df, they are same. Okay, so when they are same, it means that the x will satisfy both of them. Understand? Okay, or the x will belong to both of them because x is a part of df, x is a domain, sorry, x belongs to domain f and x belongs to domain g, and both domains are equal. It means that the functions are going to be equal, the ranges are going to be equal, and the functions are going to be equal. So that is what your identical function means. I hope this thing is clear to you. Okay, now we can take some examples to have more clarity on the identical function. Okay, let's say that we have two functions. First function is uh, I have fx equal to I have fx equal to x, and I have gx equal to under root of x square. Okay, now I have to check if both of them are identical functions, if f of gx, sorry, if f of x is equal to g of x. Okay, so I have to check if both of these functions are identical. Okay, now first of all, see here, we will start with f of x. Okay, now we have to check if both of them are identical. So what do we need to check? we need to check their domains and we have to relate their domains. We have to figure it out if d of f is equal to d of g, and then we have to figure out their ranges, and we have to see if range of this function is same as range of this function. If both things are fine, then we can say that this function is equal to, or both these functions are identical. Okay, so the given function here is fx equal to x. Okay, now for this function x, the domain df, it's going to be, you look at this x, okay, this is just variable x, it can take any values. Okay, so there is no restriction here on the, there is no restriction of any value on the domain. So this is this domain, it's going to be minus infinity to positive infinity, or I can say all real numbers, right? So if the domain is all real numbers, it means the range is going to be the same, all real numbers, right? Now let's check it out for gx. Okay, gx. Okay, now see here, I have just mentioned here the range. Okay, but what we need to do is, first we need to check the domain for this function and then for this function. Okay, because first thing is that the domain should be same. When domains are same, then automatically the ranges will be same too. Okay, so here gx is here under root of x square. Now some of you may say that now this is going to be very easy because under root of x square, it's going to be x. But now, if you are thinking in that direction, then you are going wrong. Why? Because according to the definition of the square root, if we take under root of this x square, then what's going to be happen? It will give you mod of x. Okay, now why I am saying this, okay, because see here, the given function gx is x under root of x square. Okay, now you can put any value of x here. For example, here you can put x 0. For 0, it's going to be, for 0, this is going to be 0, right? For 1, it's going to be under root 1 square, which is 1. For minus 1, it's going to be minus 1 square, which is again 1. Okay, so same for minus 2, it's going to be minus 2 square, which is 4. For 2, it's going to be 2 square, which is under root 4, sorry, and here under root 4. Okay, so what does it mean? It means that every time when you are going to put here negative or positive values or 0, you will get the positive values, right? You will get the positive values. So here x square under root of x square, it's going to be your mod x, right? Because your value is going to be positive. Okay, so it's not going to be x. Okay, it's not going to be x. Why? If it has to be x, then here it should be minus 1, but here it is plus 1. Here it is 2. Here it is 2. So how these values are coming? Because this is mod x. Okay, so your gx, it's going to be mod x. Now we know that if it is mod x, then this mod x will behave here as x if for uh, x, or we don't have to go that far. Here simply, what does it mean? Okay, now here we can see that the range for modulus function, what values it can take. Here you can see I've given it negative value, I have given it positive value, I have given it 0. So it means that the domain of g, it is again minus infinity to plus infinity or real number, right? Which means that domains are fine. Domains are fine. Now df is same as dg, but what about the range? Okay, now the problem here is that here we have identified the range. We have said that the range, it will take all the real values. Why? Because here your function is x, okay? But here we know the range of modulus function, it will always gives us the positive values, right? So here positive values and 0. So here the range of this function, it's going to be 0 to infinity, positive infinity. Now you can see here the range of this function is r, and here the range of this function is close interval 0 to open interval infinity, right? So which means that r of f is not equal to r of g. Okay, so that's why these are not the identical functions. I hope this has made sense to you. Okay, now sometimes you may come across a question where they may ask you about that. Sometimes I have seen this type of question uh, at lots of places where you are asked to find the value of x square and you are given with the option of x minus x, then plus minus x, then here mod x. Okay, so always go for this value. Mod x is the right answer, because here I have shown you it has to be positive. See here, it has to be positive. It cannot be plus minus, or it cannot be just x. It has to be absolute value function x. Understand? So this is it. Okay, we'll see few more questions, interesting questions. Okay, so take one more question, and the next question is fx is equal to under root 9 minus x square over under root x minus 2, and gx is here 9 minus x square over x minus 2. Okay, now in this question you have to find find x for which fx is equal to gx. Means that you have to find all the values of x for which these two functions are identical functions. Okay, this is very interesting question and very important questions, because this question will explore your thinking process. Okay, now see here, again the same thing here is that most students, what they will do, they will say that this is under root 9 minus x square in the numerator, and here we have root x minus 2 in the denominator, so we can just take the common root and then it's going to be the same thing. Now this is not the case. If they have given you this question and they have separated the roots, then it means they have done it on purpose, and we have to figure it out. Okay, so let's start with your fx, right? Let's start with your fx. Your fx is root of 9 minus x square by root of x minus 2. Okay, so here what we can do here is that now this function, if you look at this function here in the denominator, you have root of x minus 2, which means that here from here I can say that this thing, it cannot be 2, because the moment it's going to be 2, it will become 0, and this whole function, why? Because 2 minus 2 is going to be 0. So anything divided by 0 is undefined. So if this function has to stay valid, then we have to make sure the denominator should not be equal to 0. Okay, so it can be more than 0. It has to be more than 0. Okay, x has to be greater than 0. Okay, so not greater than 0, but greater than 2. Why? Because if it is 2, then 0, and if it is less than 2, then it's going to be negative, and you cannot, then we will go into whole different world of complex numbers, right? So this has to be, here x has to be greater than 2, but this is denominator. We'll figure it out later. First, come to the numerator. So in numerator, we have 9 minus x square. Okay, so this 9 minus x square, it can be written as, first of all, this can be written as what? Now, this is 9 minus x square. Okay, so this whole thing has to be greater than 0, right? What does it mean? Okay, what does it mean? See here, in numerator you have under root, and you have this thing written inside the under root. So if the numerator has to be valid, see here, if you have to find out under root of something, so this value must be 0 or greater than 0. So it means 9 minus x square, it should be greater than equal to 0. I hope you agree with me, right? If it is less than 0, then this thing is not going to be valid. Why? Because then it's going to be root of some negative numbers, and then we will jump from real world to the imaginary world, complex numbers. Okay, so this has to be greater than equal to 0. Only then this root function is going to be valid. Now from here, if I take minus common, so can I say that x square minus 9 is less than equal to 0, right? And from here, this is going to be x square minus 3 square less than equal to 0. So a square minus b square, it's going to be x minus 3 and x plus 3 less than equal to 0. Okay, so this is going to be my numerator part. Okay, this is going to be my numerator part. Okay, so if I have to solve this inequality, now see here, I have to draw a number line. Here I have minus 3, here I have 3, right? So this is this represents this point, because x of minus 3, this is this critical point, and this 3 comes from here. Okay, now you can take any value in this interval 3 to infinity, let's say 4. So for 4, if you put 4, this whole function is going to be positive, right? 4 minus 3 positive, 4 plus 3 positive. So here positive. Now you can apply wavy curve method. Now see here, look for the expression that has 3 in it. Okay, 3 in it means this one, and look for its exponent. The exponent is 1. Okay, when the exponent is odd, it means the sign will change, negative, then again here positive. Okay, now what we need to find out here, less than equal to 0. Less than equal to 0 means we have to include these points. Okay, so solid dots, right? So less than equal to 0 means the negative interval. So it means that here your x will, for numerator, your x will belong to minus 3 to plus 3. Understand? And come to the denominator part. This is here, I'm writing numerator. Okay, come to the denominator part. denominator part. So this denominator part, it's going to be valid when this thing it's going to be greater than 0. So it means that x minus 2, it should be greater than 0. Now here we said greater than equal to 0, but here we cannot say greater than equal to 0, because the moment it's going to be 0, this whole function will get undefined, right? So just greater than 0, right? So it means here, from here, your x is going to be greater than 2. Okay, so from here, if you see, x will belong to your minus, sorry, 2 open 2 plus infinity, right? Now this x, okay, this x is valid for, sorry, this function in the numerator, this piece is valid for this x, and this piece of function is valid for this x. So function as a whole will valid for the common values of both these domains, right? See here, what I'm trying to say is that this thing is valid for this domain, and this thing will stay valid for this domain. If both of these has to be valid at the same time, then we have to find the common ground, right? So how can we find the common ground? See here, this is your minus 3 2 plus 3, and this is your 2 to infinity. So here you have 2, and here 2 to infinity. So 2 to infinity, this is your hollow dot. Okay, so what's going to be the common ground? The common ground, it's going to be this one, right? So it's going to be so for fx, fx for fx, the domain df, right? Df, it's going to be 2 to 3. Why? Because see here, it says greater than 2 means 2 to infinity, 2 to infinity, and this one says minus 3 to 3, minus 3 to 3, and these points are included. So when you have to find the common region, what's going to be the common region? From this 2 to this solid dot 3, right? So open bracket 2 to closed 3, right? So I hope this thing is fine. Now come to the second part, gx. Okay, now gx, what it says, now gx here is g of x is root of 9 minus x square by x minus 2. Okay, now see here, what we will do here is, now we have just one root and everything is written within the root, right? So which means that this whole thing will be valid when, if this is going to be greater than equal to 0, right? So 9 minus, what it implies is that 9 minus x square by x minus 2, it must be greater than equal to 0. Only then this root function is defined. Otherwise, we will jump into another universe of complex numbers, right? So from here, I can say x square minus 9 by x minus 2 is less than equal to 0. Okay, so from here, x minus 3, x plus 3, and here x minus 2 less than equal to 0, right? So again, wavy curve method we are going to use. I have told you wavy curve, it's a lifesaver. This is your minus 3, this is your, sorry, it's going to be this is going to be no, this is going to be, critical point is 3, here minus 3, and here 2. 2. Okay, now we know that if you take any check for any extreme end, you can start with the left or the right extreme end. Take any value 4. For example, here take 4. 4 minus 3 positive, 4 plus 3 positive, 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 4 minus 2 positive. It means here it's going to be positive. Okay, now go for this expression, x minus 3. What's the power here? Exponent 1. So the exponent is odd, it means sign will change, right? Now look for the exponent that has 2 in the expression. This one, what's the power? Odd. Odd power means sign will change, positive. Now look for the expression, look for the exponent that has minus 3 in the expression. That has minus 3 in the expression. So this is basically x minus minus of 3. So again, the power is odd, so the sign will change, negative. Now we have to find less than equal to 0 means that this region, negative and negative. Okay, so it means from here, your x belongs to minus infinity to minus 3 union less than equal to 0. So I have to include these points. Okay, so union what? Union 2 to 3, right? Union 2 to 3, right? Now we need to find out the common grounds for which these functions are going to behave identical, right? So what's going to be the common ground? Okay, so we have to find that common ground. Now see here, there is one thing here. You cannot take this one, cannot include this one. Why? The moment you are going to include this 2 here, 2 minus 2 is going to be 0 and it's going to be not defined. So we have to put here open bracket. Why? Because x should not, yes, this must be greater than equal to 0 and x should not be 2, right? So now this is this x means that it is the domain of function g. Now we have domain of function f, we have domain of function g. We have to find the common ground where fx and gx are going to be same. So you can see here what's going to be the common part. It has 2 to 3 open closed bracket and it has this same thing here too. So we can say that for this interval, okay, so for this interval fx is going to be gx. So I can write here fx is equal to gx for all x belongs to open interval 2 to closed interval 3. Okay, so this is going to be your answer. Okay, I hope you have gotten it. Okay, so that's how you have to approach the problems that involves your identical functions. Okay, now let's